Okay, so I wanted to do a quick explanation of the spinal cord case study so that you truly got an appreciation of decussation, ascending tracts, descending tracts, and the effects of spinal damage. Now, the first thing that the case study asked you to do was to do a base schematic of the spinal cord. So if we just draw that quickly. Yes. We put in our grey matter. And we'll just shade it slightly so that you can distinguish the grey from the white matter. And if we label it up, so this is the dorsal horn. This is the ventral. We have the dorsal root ganglion. And we have our spinal nerve. Now the next thing that you needed to do was to then indicate the individual tracts that are on here. Now remember, they're on both sides. So let's put on our dorsal column tract. So here and here we had the spinothalamic tract, the lateral corticospinal tract. So this is the lateral corticospinal. Here is your spinothalamic. And we have our fasciculus conatus, which does the arms, and our fasciculus gracilis, which does the legs. Now obviously remember, these are on both sides. The next thing it asked you to do was to do a very simple map of the sensory pathway. So further up at the top, we draw a brain in sagittal section, doing a little bit of a bulge just to represent the medulla oblongata. And I'm just going to indicate on here, using a circle, the thalamus. Alright, so the sensory tract, remember that the sensory comes in, we're talking about the left side. The sensory comes in. Okay, so the sensory has come in into the dorsal horn, at which point remember that the interneuron decussates. It actually goes to the right-hand side, to the right spinothalamic tract, at which point that tract ascends. It will ascend up on the right-hand side of the spinal column to the thalamus, at which point the third order neuron, the interneuron, will then go to the sensory cortex on. Now it is going to communicate with another interneuron in the cortex, and this will communicate with the motor neuron coming down. So the motor neuron is going to go down past the basal nuclei, at which point it decussates in the medulla oblongata and then comes down the spinal column on the side that it is going to represent. And it will come down to the lateral corticospinal tract, where it will then go across to the ventral horn, synapse with the second motor neuron, and exit out on the left-hand side. So in green we have our descending tract, and in orange we have our ascending tract. So this is a basic circuit for sensory and motor. The slight complications, obviously, is that generally speaking all of your sensory does decussate at the spinal column, but there's always an exception to this rule, and that exception happens to be your dorsal column. These guys, after synapsing with an interneuron in the dorsal horn, actually ascend on the ipsilateral side. That means it ascends on the side that it represents, and it decussates at the medulla to the thalamus and then goes to the cortex. So that is the only sensory perception that goes up the side of the spinal column on the side that it represents. Now, if we look at our patient, he had on the right-hand side decreased in pain and temp, and on the left-hand side, decreased lower leg strength and decreased touch and proprioception, to the lower extremities. Remember, all of this happens to be lower extremities. Now, if we take the easiest pathway, we look at the motor pathway. So he has decreased lower leg strength on the left-hand side. Now, if we look at this pathway, this automatically tells us, we know that it decussates in the medulla oblongata. It tells us that this lateral corticospinal tract is the one that is injured. So we know it's left-hand side, and we know that it's the lateral corticospinal tract. If we look at our touch and proprioception, then we know that the conatus and gracilis, again, because it's represented on the ipsilateral side, we know that these are affected. Now, to explain the right-hand side, remember that this one comes in from the right-hand side, synapses, but this decussates to the left spinothalamic tract before ascension. So we know that the left spinothalamic tract is now affected. So this entire section is injured. The other information that we can get from his decrease in touch and proprioception is that the fasciculus conatus does upper extremities, that does arms. Fasciculus gracilis does legs. Now, we were told that he had potential breaks at C1, C5, and T9. Because his upper extremity is fine, this indicates that the break must be T9, because the gracilis is showing injury, but the conatus aspect, which is actually much smaller in the lower extremity, is not showing any differences. If the break had been C1 or C5, we would have seen effects in the upper extremity. The remaining questions are about how you know it's the tract and nothing else. This part between here and here is the root. Now, the dorsal root only carries sensory information. The ventral root is only motor information. But we have a mixed bag in terms of symptoms, so it cannot be just a root. Once they merge and exit, they are known as the spinal nerve. It cannot be just the spinal nerve because we have both left and right. If it was only the one spinal nerve, we would only see effect on that one side, but actually we have effect on both. We also know that it's the tracts that are involved because of that foot flexor reflex. Now, this foot flexor reflex actually involves a pathway that comes in on the dorsal side. The interneuron goes from the dorsal to the ventral horn, and then immediately exits. This foot flex reflex does not go up through a tract, and that particular reflex is absolutely fine. So we now know that this area here is what is injured and not the grey matter.